So today we're going to finish lesson 4.2. We're calling this part 2, and what you might want to do on the top of your notes, I do not have this slide. I was just trying to save a little bit of paper. So to make it a little more obvious when you're flipping through your notebook, you might want to write lesson 4.2 a little bit larger somewhere up in that white space at the top. I know it's printed in real small letters at the top, but as you're flipping through your notebook, you might want to make it a little bit more obvious. So today, we're going to look at another way of expanding binomials. You know now how to use the triangle, Pascal's triangle. We're going to eventually talk about the binomial theorem as an alternative to expanding binomials to any power. But the binomial theorem is much more than just a way to expand binomials. We also are able to use it to answer certain types of probability problems, and that's where this lesson is eventually going. So, the bad thing is to jump right into the binomial theorem. It means that you've had some prior knowledge of certain math topics which you have not had. So we're going to have to lay a little bit of groundwork before we can get to actually using the binomial theorem. And that's what this slide is about. So bear with me. We're going to take it step by step, and eventually we're going to get to the binomial theorem. But if we don't do this first, some of what we're going to be talking about is not going to make any sense. All right. The binomial theorem involves, as you can see there at the top, this math concept of combinations. And a real simple definition of combinations in a math context is it's all the different ways that we can choose small groups out of a big group. And I gave you a real simple example of a classic math combination problem. Here it is. If I have a classroom full of 8 students, how many different 3-student study groups can I make out of those 8? And that's what combinations are all about. They help us answer questions like this. So I want to show you the official combination formula. Okay? What this means is, obviously the C stands for combination. The N in this stands for the total number of people I have to pick from. So right underneath the N, I'm going to write the number 8. Now typically we would have the 8 right there where the N is, but just bear with me for a second. This R number is always the smaller number, and it's how many, in this case, it's 3 because I'm picking 3 people groups of 3. So, you should, by this point, already know this formula, but you don't, so I'm going to walk through it with you. This formula for finding this, for calculating this, looks like this. We're going to take this number n, and we're going to do n factorial. Now, some people they've seen this before. They've had exposure to what it means to be a number factorial, but others haven't, so we're going to talk about that in just a moment. The denominator is going to be r factorial multiplied times n minus r factorial. If you've never seen that exclamation point in a math context and you've never heard of the word factorial, now's a great day to get some understanding because this is going to come up again in future math classes. So let me just go ahead and use this formula for this particular problem. 8C3, n is 8, so I'm going to be calculating 8 factorial. A number factorial means this. 8 factorial is 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Any number factorial, you start with that number, and then you multiply, decreasing by 1, until you get down to 1. Okay? Don't have to do anything yet with your calculator. We're just going to keep filling in the formula. R factorial is 3 factorial, which is 3 times 2 times 1. N minus r, in this case, 8 minus 3 is 5. That makes 5 factorial. So we're just going to keep on 5 times 4 times 3 times 2 times 1. Looks kind of messy, but fortunately, factors will cancel. All of these are factors, 5 times 4 times 3 times 2 times 1. We can cancel those. 6 is the same thing as 3 times 2. We can cancel these. So what's left? 56. So what we've discovered is that there are 56 different 3-person study groups that we can come up with out of a class of 8 students using what is known as the combination formula. Well, let me show you how we can do that real fast using your calculator. All right? So the first thing we're going to do with using your calculator is we're just going to type in this bigger number called n. So if your calculator has anything on it, just clear it and type the number 8. That's the bigger number. Now you're looking for a button on your calculator that reads PRB. It's a short for probability. Does everybody see that? I want you to press the PRB button, and that's a little sub-menu that should give you access to these. The factorial may not be in this order, but it should say NCR and then NPR. Everybody see that on your window? Okay, I just want you to arrow over until you've selected NCR, and then you can press the Enter key. So now when you're looking at your screen, it should look something like this. 8 NCR. Everybody good? Now you're going to enter the 3, and then you can press the Enter key. And then it should show 56. Just hold on to it. Okay? Any questions about, first of all, what a combination is and how to get to it pretty easily with your calculator? Any questions? Yeah. That's actually a good question. The P stands for permutations. Permutations are this. How many different ways, if I put all of you in a row up here to take a picture, like a single file line facing that wall, how many different ways can I arrange you for that picture? That's what a permutation is. But it's not involved in the binomial theorem, so I'm not going to cover that today, just so you know the difference. Okay, so now that you've had a little bit of a taste of combinations and how to calculate them in your calculator, let's take a look at how we can use the binomial theorem to expand any binomial to any power. There's going to be a lot of similarity to what you did last night. If we were using Pascal's triangle, can somebody tell me the row of the triangle? What are the numbers on the row of the triangle that I would use for exponent 5? Yes?
1, 5, 7, 7, 5, 1.
Very good. I'm just going to write those down so you can see the similarities between these two methods. Well, instead of getting these coefficients from a row of the triangle, we're going to get these coefficients by calculating combinations. Here's how it works. So here is the theorem in using the theorem to expand. I'm going to start off with 5 NCR 0. Okay, go ahead and find out what that is. 5 NCR 0. Did you get 1? Okay, that's what the triangle says. So instead of getting that coefficient from here, we're going to get it by calculating combinations. The rest of this works just like you did last night. A is going to start off being raised to the 5th power. B is going to begin being raised to the 0. There's no difference in how the terms inside the parentheses work. Yeah. whatever that exponent is how you'll start. Good question. Okay? To get the next term, I'm going to calculate 5c1. And what will the exponent for a be based on last night? A to the fourth, and b will be to the first. Okay, what's 5c1? 5? You should have gotten 5 when you did 5 NCR 1. So the only difference between these two methods is in how these coefficients are arrived at. Triangle, we got to pick a row. Theorem, we're going to use our calculator and calculate combinations. So the next one, I would calculate 5c2. A to the third, b to the second. The next one, you would calculate 5c3. A to the second, b to the third. The next coefficient should be 5c4. A to the first, b goes up to the fourth, until finally we're down to 5c5. A to the 0 is just 1, b to the fifth. So cleaning this up, we're going to end up with the same answer that we got using the triangle. 5c0 is 1, b to the 0 is 1, multiplied by a to the fifth, and we get a to the fifth. Okay, 5c1 is 5, this is 5, a to the fourth b, this is 10, a cubed b squared, 10 a squared b cubed, 5ab4, and b5. So the red would really be the final answer to this. Any questions? Yeah. The big advantage to this is going to come, I think, when you see the probability. Let me kind of give you a sneak peek of what I mean by that. Sam, let's see if I can get your question. Yeah, I want you to write this every time. Definitely. I'm kind of getting ahead of myself a little bit, but maybe this will help. Why this binomial theorem? Each one of these terms in the expansion represents a different answer to a probability problem where there are two possible outcomes. Here's what I mean by that. World Series starts tonight. Big fan of baseball. Okay. A guy comes up to the plate. I want to know the probability of him getting a hit or not getting a hit. There's two possible outcomes. Either he's going to get a hit or he's not. If I let A represent the likelihood that he's going to get a hit, and B represent the likelihood that he's not going to get a hit, and he's going to go to bat 5 times, which is what this exponent indicates, each one of these gives me the result of the scenario. For example, this, since A represents getting a hit, this is the likelihood of him getting a hit 2 of the 5 times. Just going to that term, I've got that answer. This represents him getting a hit all 5 times. So each one of those terms is the answer to a particular probability problem involving two possible outcomes. Like flipping a coin, heads or tails. If you flip it 100 times, and you have equal outcomes, heads or tails, what's the likelihood that you're going to get heads 80 of those times? Well, we would just go to the particular term in the expansion that has that exponent 80 for heads. That's the great thing about the binomial theorem. So it does expand You don't have to have a triangle. You don't have, if I ask you to expand a plus b to the 15th, well, if you didn't know the theorem, you're going to have to build the triangle through 16 rows before you can start doing the problem. Don't know if that answered or not. But it's going to come up again in your future math classes, so I want you to be ready. Okay, I'm going to skip letter B for sake of time, and let's work on letter C. Use the binomial theorem to do the expansion. So I'm going to have to pick up the pace a little bit. My first term is going to be calculated like this, 5c0. 3x is going to be raised to the 5th. 2y is going to be raised to the 0. Somebody raise your hand and tell me how I will calculate the second term. Yes?
5c1 times 3x to the 4th power times 2y raised to the 3rd power.
Very good. All right, John, give me the next term, how I would calculate it.
5c2 times 3x to the 3rd times 2y to the 2nd.
Good. Kennedy, next term. Okay. Meredith, next term. Okay. And Izzy, last term. All right, now let's do some cleanup. Have you already discovered this is the same, similar problem that we did before? 5c0 is what? 1. Let's simplify 3x, the monomial 3x raised to the 5th. 3 to the 5th times x to the 5th. Okay, 243x to the 5th. So the blue is going to represent our final answer. Everybody see how we got 243x to the 5th? Okay, 5c1 is 5. Abigail, if I raise the monomial 3x to the 4th, what is that? 3 to the 4th times x to the 4th. Okay, and that needs to be multiplied by 2y. So let's put it all together. 5 times 81 times 2. 5 times 81 is 405. 405 times 2 is 810. X to the 4th, y. Okay, here we are at 5c2. What is 5c2? 10. What is 3x, the product 3x raised to the 3rd? Chris, what is that? 3 to the 3rd times x to the 3rd. Okay, and what's this going to be, Chris? 2 times y to the 2nd. Squared. All right, put it all together. 10 times 27 times 4. What is it? 1080. X cubed, y squared. 5c3. 10. This is going to be 9x squared. This is 8y cubed. 180. It's 10 times 9 times 8. 720. X squared, y cubed. Okay, I'll just come down here. 5c4. 5 times 3x. Dalton, what is this 2 times y raised to the 4th? 16. All right. And put it all together. 15 times 16. 240. X, Y, 4. And then finally, 5C5 is just 1. 3x to the 0 is 1. What is this, Meredith? 2y. 2 times y raised to the 5th. 2 to the 5th times y to the 5th. 32 to the 5th. And we are done. Okay? Questions about the binomial theorem, how it works when we expand? Any questions? Yeah? I know what you're saying. This really isn't 5c to the 4th. I know that sounds like it's an exponent. It's really not. In your calculator, you just do 5. You just press the 5. And then PRB. And then arrow over to NCR. Enter. And then put in 4. And then enter. It's short for probability because that's really why we use this. All right. Now, problems 8 through 13 look like this. So there's really 3 types of problems you're going to be doing on this assignment. So let me get you ready for 8 through 13. What this wants to know is, how do we come up with just the 6th term of this entire expansion? I do not expect you to write down all 11 terms and then circle the 6th one. That'd be a lot of work. Let's see if we can just think about how we would come up with just the 6th term out of the 11. Well, since this is raised to the 10th power, and I know I'm going to have a combination factor, I know that the number to the left of C has to be 10. This is another advantage to the theorem versus the triangle. Yeah. Okay, hold on. My bad. If you'll just hold your questions for just a second until I get through the example. Okay, for the 6th term of this, let's think for a second. At the beginning, for the first term, what was the number besides C? For the first one, 0, right? We always start with 0. So for the second term, what would be the number besides C?
6.
For the second term? 1. The next term would be 2. The next term would be 3. Next term, 4. The 6th term, 5. Do you see how that works? So 10C5. Because we start at 0 and we count up by 1. Okay? Now, for the 6th term, C is going to have what exponent? Well, what did it start with at the very beginning? 10. It started at C to the 10th, C to the 9th, C to the 8th, C to the 7th, C to the 6th, C to the 5th, right? I'm at the 6th term. Do you see how that works? We started at the 10th, C to the 10th, and then you just count down. So this should have the 6th term, it should have an exponent 5. If you're not following me, just raise your hand. Let me know. Okay, so here's 2 ways really of coming up with D. This is always true. I'm going to back up a step, and that's kind of messy. Do you notice, did you pick up on the fact that the number to the right of C and this second exponent are always the same? 1, 1, 2, 2, 3, 3. Did you pick up on that? It's always true. So using that knowledge, that helps us, if we don't already know, that helps us come up with the exponent for the second term inside the parentheses. Here's something else that's true. These exponents always add up to this number. Okay? If they don't, something's wrong. 5 plus 5 equals 10. Okay, now we just need to calculate 10C5. So get your calculator, 10 NCR 5. Okay? Zach, got it? 252. C to the 5th, D to the 5th. That's our answer for the 6th term. So please don't write down all 11 terms and then circle the right one. Just think about what the 6th one would be. Let's try this one. The 3rd term of this expansion. So let's start with the combination factor. 6 goes to the left of C. We started at 0 with the 1st term. Where are we at the 3rd term? Did you pick up on another little hint on how to get that 2nd number? Did you? Go ahead. You're okay. Like this was 5 for the 6th term. It's 1 less. Yeah. 2 for the 3rd term. 5 for the 6th term. Do you see that? Okay. Kennedy, what are we going to raise A to for the 3rd term? It started at the 6th. Be A. Well, if it started at 6 for the 1st term, then it went to 5th for the 2nd term, where is it now for the 3rd term? 6th for the 1st, 5th for the 2nd, 4th. Okay? Meredith, what about B, or 2B actually? Negative 2B. 2. And that one's easy because 2 things. These have to match. The number after C and the 2nd exponent always have to be the same. And these exponents have to add up to this number. Yeah. You can. Yeah. This is the difference. Yeah. Good? All right. Let's find 6C2. 6 NCR2. What you got, Riley? 15. A to the 4th. And this becomes positive 4B squared. Put it all together and we have 60 A4 B2. Questions on how to find a particular term? Yes? Okay, everybody good? All right, one type of problem left. I have 2 examples. You need to make a little bit of an adjustment. I realize this later. It will make more sense on your notes if you, on this line right here where it says the probability that 4 of her, I just said 4 of her children. It should say 4 of her 5 children. So you need to just insert that 5. That's pretty huge. Without it, the problem doesn't make much sense. So here is how we can use the theorem to answer some probability problems that involve 2 possible outcomes. What are our 2 possible outcomes here? Boy or girl. Okay? Now I'm going to start with what they tell me. They're equally likely to have a boy or a girl. So percentage-wise, that means 50% of each. Equally likely means that there's a 50% likelihood of either one. So to begin with on these probability problems, you're going to write down the percentage likelihood of each event happening. Okay, use the Binomial Theorem expansion to determine the probability that 4 of her 5 children are girls. Okay, so the way I set these up is this first one, I'm just going to label according to what the problem says. I'm going to call this girls. And since it says finding out that 4 are girls, I'm going to raise the girls percentage to the 4th power. If it had said the probability that 3 of the 5 children are girls, I would have raised it to the 3rd power. And if she had 5 children and 4 of them are girls, that means 1 of them had to be a boy. So again, this represents just one of the terms of the whole expansion. And using the theorem, we need to make sure that we have a combination factor. So what is the number going to be to the right of C? Remember what we said earlier? This should match which exponent? The second exponent. Remember, we just talked about that. Whatever this, if you set it up this way, then you can just look at this second exponent, and that will be the number after C. So here we go. Ready with your calculator? We can do all of this in one line. Ready? Clear it if you need to. 5 NCR 1 times 0.5. And if you don't know how to raise something to a power, it's that key with, it's like an upside down V, raised to the fourth, times 0.5, and we don't need to raise that to the first. Okay, I need for somebody, Abigail, can you read me what's on your display? The whole decimal. Is that the whole thing? Okay. This is decimal form. Tonight, I want percent form. Okay? I want these answers in percent form rounded to the nearest hundredth. Is that what I said on there? Yeah, it's on the last slide. So percent form means I'm sliding this 2 places, and I'm going to round it 2 decimal places for hundredths. This would be the final answer like you're going to show it tomorrow. This is what's great about the theorem. The second, if you set it up like this, what I mean by that is if you'll just write down what's given in the problem, what they're asking you to find, then this second exponent will always be the same as that number after C. We'll do another one. Here's another probability problem. By the way, when you're doing number 7 tonight, look at this problem, because it's a lot like it. Same thing for number 20. While you're watching the World Series tonight, you can do this problem. It's perfect. World Series. No baseball fan? No? Okay, pitcher. He's just as likely to throw a ball as a strike. That means there's a 50% likelihood of either. I'm going to start by writing down those percentages. 50-50. Find the probability that 7 of the first 11 are balls. Okay, so what I'm going to do is, since it wants to find out the number or the percentage of balls, then I'm just going to always stick with this first one. I'm going to call that balls, and I'm going to raise that to the 7th power, because it says the likelihood that 7 of the 11 pitches are balls. So, Izzy, that means the exponent for this one will have to be what? You threw 11 pitches, 7 are balls. That means how many were strikes? There you go. Okay, now my combination factor, what goes to the left of C, John? Okay, what goes to the right of C? Yeah, 4. All right, grab your calculator. You're off and running. 11 NCR4 times 0.5 to the 7th times 0.5 to the 4th. And when somebody gets the decimal, I want you to read me the whole decimal. Go ahead. Okay, I need to see who got that. All right, now let's turn it into percent form. Yes? Let me go ahead and get this percent form, and then I'm going to answer that. So percent form, it should be, this is what you're going to bring tomorrow, 16.11%, rounded to the nearest hundredth. Okay? Any questions? You see the assignment. It's on the last slide there, printed out for you. Let me know if you have any questions.